Good afternoon. Bob Davis is the name. I'm here to talk about the extensions for the ODBC interface called Adhoc indexes, and we'll see that that title might actually change down the track. The ODBC interface is a way of extracting data from Jade in a relational manner. So you have a select statement, and it's a pseudo select statement, whereby we're saying we want to look at all the withdrawals that are past that date and are greater than $10,000. Now, if we have, what Jade will do is analyze that where condition and say, have I got a collection over withdrawal that's ordered by transaction date? If it does, then it will use that collection to retrieve the data and minimize the impact that this request will have. So it'll only read the data that it has to. If it doesn't have such a collection, then it's got to do in all instances and go through every instance of withdrawal to find the records that are associated that match that condition. It gets worse if you have something like that, which is a join, where we're saying we want to find all withdrawals that and deposits that match. We're looking for some sort of suspect transaction or something like that. If, in this case, we need two collections, one by date, at least, and one by amount on deposit, to actually do that meaningfully. If we didn't have those collections, and we had a large amount of data, this would take forever. Because for every withdrawal, we have to go through every deposit to find the matching entries. So when you design your systems, how many collections you have becomes a function of what do I need for reporting versus what's the performance impact of maintaining those inverses as we go through when the transaction is being applied. So unfortunately we never have enough indexes for reporting often. So what this feature does is provide the ability to dynamically add indexes without the need to reorganize, to do a reorganization. So you can, and those indexes will then be used by the ODBC interface, as well as looking at all the Jade collections that are available and looking at their keys. You will also look at the ad hoc indexes that are being defined and choose those indexes if the keys match and use them to access the data. And that includes the ability to do joins between different where condition. So the concept is that you only build these indexes when you require them. So maybe in a period where, at the end of the week or the end of the month, you want to do a whole bunch of batch reporting, you build the indexes, run your reports, and then you drop them again. So you don't have the overhead on your system of maintaining these indexes for the rest of the period for nothing. Only when we need to run that reporting. And then when the next period comes along, you build the index again, run your reports, and drop them again. Now the indexes are maintained globally, but they're actually maintained as part of the ad hoc browser. So you go to your class browser, and do a browse. There's an ad hoc index that allows you to maintain the ad hoc indexes for that schema. There is also an application that runs on the root schema that allows you to maintain these indexes for all schemas and doesn't require the IDE to be present. So the idea being that you can actually run these in production mode. You can extract the indexes into an XML file and load them back in, and Jade Client allows you to do the loads, do the builds, check the statuses of the indexes and so on, so you can actually do all that in a batch manner programmatically without having someone to check all that information. So once an index is built, it's then maintained by a separate process that runs in the background that goes through all the audit logs and finds the entries that have been added, deleted, and where the keys are changed, and updates that collection. The idea here is that we are not impacting, or we're minimizing the impact that these indexes have on your production system. So when the transaction's being committed originally, that's going to add that index, add that entry to the withdrawals or whatever it is, we're not impacting that transaction. We're coming along after the event, finding where these things have happened in the audit trail and updating that index. So the other effect of that is that the index will always be slightly behind your updating your transaction state of your system. It depends on how much time that the chasing application gets to process that, how busy your system is.
Oh, will they run off journal swaps or journal rights?
It uses the physical journals, scans the journals, and actually will hold them in place.
Yeah, but at journal swap time, or as the journal's being written?
As the journal's being written. But it will only, it goes and asks the journal, has anything changed, and if it says no, then it won't actually do anything further. So there is scope for performance improvement in what we've done here.
Could you run on a secondary then?
Yes. You can run the indexes on the secondary, yes.
But can you run the process on the secondary only?
No, not currently. Okay, so a diagram of some of this is that essentially in root schema we have a bunch of system classes that there's a root object that holds a definition of all the ad hoc indexes. Each index will have a data dictionary created for it once it's made live. And once it's become live, well, this controller app runs in the background. It will, when you ask it to build the index, it will create the dictionary. It builds it from the existing instances, and it does that in an unaudited manner, so that it's faster and it's not going to have an impact as much impact on your system. And then once it's built those indexes, it turns on the auditing and goes and scans the audits for any changes that have taken place. And that application will sit there in the background doing that while there are indexes live. So we'll do a quick demo.
Well,
how long does it take for it to build from instances if you've got a very large number of instances?
You'll see a demonstration of that shortly, okay, if you don't mind.
About as long as it's going to take to iterate.
Yes.
Oh,
Okay, so here we have a schema with a bunch of classes that are used for testing the ADBC. If we go to Browse and Ad Hoc Indexes, and we'll add a new index. These names are because I use A for ascending keys and D for descending keys. This time of day I need my glasses. And we'll add a key of name and ID. Yes, well, there we go. It says you can't name it the same thing as a class. Okay, so we have an index by name. So what's happened here is all we've done is create the skeleton definition of this index. It's not live. Nobody's taking any notice of it. It's just sitting in the background ready to go. We can now, you'll notice down the bottom here there's a run ad hoc index controller app. That's automatically started for you, but and it will actually be started when we do the next process, but it doesn't need to be running at the moment because there's nothing for it to do. So there's no point in it actually being running it. So if we run that, it's just going to say, oh, I've got nothing to do and go to end of job. So if we now build that index, now this one has only got 98 entries in it, and well, it's got 100. I forgot to delete the 2 that I added in the part of the demonstration. Okay, so that index now is live. So if you run an ODBC query, it will say, okay, if I need a query over A1, A2 that uses name, then I can use this index. And it will do that. We'll do some of that shortly. If I try and create an index, no, it doesn't matter what it's called, and same membership. Must be that time of the afternoon. What have I done? Oh yes, keys. So if I try and create the same index, I really do need my glasses, sorry. That'll do. Yeah, so basically there's protections in there to say, hey, you've already got this index, or something like this index defined, so why are you trying to define another one? The other one's got 2 keys, we're trying to define one with 1, so it's pointless having the second one. And we'll do the same when comparing against the Jade collections that are available as well. Okay, so well, that's the theory of, oh, okay, now what? Having built that, we run our reports, we can now say, I don't want that index live anymore. We drop it, and we'll see that the background app has gone away because it says, oh, okay, there's nothing for me to do, I'll disappear. So it's now gone back into this inactive state, waiting for us to rebuild that index again. I'm using a small one there because we're going to do a demonstration a little bit later. Thank you very much. And what key is it you get back to? I always go back to the beginning, which is sad. Okay. Now an ad hoc index has 4 states when it's defined. And first one being it's inactive, which is the pink colour we had there. So basically nobody's interested in it, it's not live, it's not being used, it's not being updated. Once we've built it, it's active and it will be maintained by the chaser information, looking in the audit trail and updating with anything that has happened to those classes. It's being built, of course, and that build process can be cancelled if you decide to change your mind. And in error can happen because we've decoupled this definition from the meta schema, from the class definition. So if you go and change the definition of a property that's used in a key, that index becomes invalid because we're not going to maintain it anymore. You have to drop the definition, you have to drop the index and rebuild it because we're not going to reorg it. It's quicker, the process is quicker to build the index than go through the whole reorganization process. As you saw, that the index is defined with a name that's unique across all schemas. Well, you wouldn't have seen that, but they are global to all the schemas, and it has to be unique within the class, normal class schema concept. It has a membership class, and you can control the ascending, descending case, sort order. We don't allow you to set the duplicates, allow duplicates, because that depends on the content of the data that you're actually going to read, so it doesn't matter. We will always allow duplicates. The ad hoc index itself is created as a Dyna dictionary, and it's created in its own partition, and as Jerry will talk about later, that allows us to build it as unaudited, so we don't have to carry the overhead of auditing all that information, of building that index. And once the build process is finished, we turn the auditing back on, and we also don't maintain it as part of the existing transactions. Again, we're trying to minimize the impact that this will have upon your existing transactions, so that we do it after the event, so that your production system can carry on as is. And we maintain it by chasing the logs in the database. And then that audit controller application, the ad hoc index controller application, will automatically start this up if you're a server node or you're a single user app server. So it will come in and say, okay, I've got nothing to do, I'll go away again, or it will perform whatever commands are required such as building indexes, dropping them, and chasing the changes. So that'll sit in the background. I think most of this is repetition of what we've already said. The last point there is that you'll notice a greater delay in audits hanging around because they won't be released until we've actually gone through and processed all the information out of them that we need. And once we've finished updating from those audits, then the database is told that, hey, that audit can now be released. In the development environment, when you click on a property that's used as a key in an ad hoc index, it will, well, when it's displayed, it'll have a key icon saying it is a key. It will list all the ad hoc indexes to which it belongs in the description, and the classes and properties you can't delete if they're being used by an ad hoc index, but you can change them. So I said, once you change it, that'll cause the index to become invalid and you have to drop it and rebuild it. When you run a reorganisation, we shut down the controller app because the database needs to be accessed in exclusive mode. And at this stage, ad hoc indexes can't be accessed from logic. But we've had some fairly strong positive interest in this whole process of saying, well, why only do this for ad hoc indexes? Why can't we use this for other processes? And so it will be, I would say it's fairly likely that this will be a feature made wider fairly shortly. As I said before, they are global, and so there is no versioning involved here. We don't get into any of that territory. We decouple those definitions from the ad hoc definition itself. Then we'll go back to the definition and, sorry, the demonstration. If I remember to run, I have to run it. First of all, I need to run the application that is the server for, you can read that, it's basically an ODBC server that's sitting there waiting for an application to send SQL commands to it. And if we drag up one of those requests that I showed you at the beginning, okay, so we've got here a request, if you can read it. I'm not sure how clear it is, but we're scanning all the deposits, and there are 1 million deposit objects, and we're returning all of those with more than $10,000.
Well, you might want to just zoom in a little bit.
I'm sorry?
You might just want to zoom in a little bit. It's a little challenging there, isn't it?
And okay, that didn't take long at all because there's about 12 seconds worth. There are currently no ad hoc indexes defined, so it had to do in all instances to achieve that result. If we go back to here now and actually add in deposits by amount. So we have one index there. This has got 1 million entries. We'll start the build of that. It'll take about a minute to build that one. And while we're doing that, we will add another one. Press the lock key, didn't I? Transaction date and amounts. and we'll populate that one. Oh, we see the other one's already finished. Now, you'll notice that the collection size there for the first one is 100. If we go to our schema and a little script here, all it does is create 2 more entries, 2 more objects in that class, for that class. And so we've created 2. Now these numbers here are updated on a timer every 30 seconds. So eventually we'll see that ticking over to 102. Seconds is a long time when you're waiting. There we go. Okay, so the other index is built. So we've got 2 indexes now that have 1 million entries in them. And if we go back to our SQL command and run that again, you'll see that it took 0.2 of a second that time to achieve the same result. And if we look at the, and I keep doing this, I'm looking at the wrong taskbar. We look at the message log down the end. Got all the noise in the world going on here. Here we go. We read 100 records of the 10,000, the million records to achieve that, because we were able to use that ad hoc index. Whereas if we scroll back to the previous one, previous one had to read 1 million entries of the 1 million, because it had to do with all instances. If we now run a query with a join, here we're doing the same sort of thing, by transaction date, where the amount's greater than 10,000 and the withdrawal's the same as the deposit. We run that, it'll take a fraction longer to run because, well, it's not too bad. And 2 taskbars on a PC should be banned. Okay, if we look down the stats on this one now, it had to read, it had to read 150,079 records to find the withdrawals, and then each withdrawal only needed 1 record to read 1 record from the deposits. Okay, so the final piece of the demonstration is nothing more than showing you, if you go to root schema, there is an app that allows you to browse all the ad hoc indexes for all schemas or a selected schema, and you can maintain them there without having the development environment in place on your production system. Any questions?
You can't add them there, though, can't you?
Oh yeah, you can add them there. You do everything the same, just there are 2 different locations for them, that's all. One destined for production mode and one for developers.
And do they go with the SCM and DDB?
No,
You have to do them separately.
you have to actually extract them and load them separately. That's a topic that might be discussed. Okay, thank you.